Hello and welcome to the demo of the new version of VCS from Symantec. Today I want to discuss how Symantec can assist with gaining control of application availability without giving up on vMotion and DRS in VMware environments. My name is Lorenzo Galelli and I'm the Technical Product Manager for our high availability solutions on virtualization platforms. So I want to talk really around how Symantec can assist with application control and visibility, especially for virtualized environments. And I think we've all seen the power of virtualization over the past 5 or 6 years now. A lot of our customers which I talk to are starting to move really from the 30% virtualized environment to around about 60 to 70%. And one of the key challenges which they experience is really how to look at what's happening actually inside the virtual machine. So it's all around application control and visibility. So as they deploy applications in the environment, what they are looking for is the ability to really feed back to themselves on really what the application is doing. Is it up? Is it down? Has it faulted? What interaction has it got with other applications in that environment as well? So one of the key challenges we see, particularly around virtualization, is how the virtualization tools can provide that feedback to the users to let them know the application's up and running. There's various ways you can probably provide that feedback today. You can deploy some type of monitoring tool or framework within the environment which monitors the application. And the key here is it monitors. There's no level of remediation or control and automation to fix the issue of the application which may have faulted. Another way to provide some level of visibility and automation is to deploy clustering inside the virtual machine itself. Now, clustering is great. It provides an automated approach and also remediation of the application. But utilizing existing clustering technology today, then typically what you have to do is share the storage between those virtual machines. And by doing so, you've got to set your virtual machines in a certain type of format. You have to utilize the likes of raw device mappings or RDMs, and typically they have to be in physical mode because the clustering solution needs direct access and control to the underlying storage. By doing so, you have to set the virtual machine to share the SCSI bus of the storage between the virtual machines, which really means you can't use things like vMotion and DRS because of the limitations which may apply. So there's fairly rigid storage compatibility control for the clusters and the environment itself. Another thing to look at when you're deploying applications in the environment is how do the applications interact with one another. And typically when you deploy an application, the application has multiple components which could be spread across multiple virtual machines. So ideally what you need is the ability to tie these applications together and control them in a unified manner. Now VMware today provides the ability to sort of do that. They utilize the vApp logical container, but the vApp container really, what it does, it brings virtual machines together, but there's no level of application awareness or really control on how you can actually determine that the database may have come online, and then you can then start the relevant tiers above that. So having a solution which manages a multi-tier application approach is key. And let's not forget about a physical environment as well. There's still going to be some physical systems out in the environment itself, so really how do you tie your physical and virtual machines together? And again, if you're controlling those as a logical entity and your physical system goes down, so let's say we're looking at a typical 3-tier environment where you have a database which is sitting on Oracle, which is on Solaris hardware, and then the various tiers above it are all virtualized. So you could be running WebLogix or vSphere in the middle tier, and then maybe Apache or Internet Information Services running on a Windows virtualized platform above that. So really, how do you control that? If your database goes down, then ideally what you want to do is stop the various tiers above that and control those in a unified manner. So again, a solution needs to be aware of what happens when the applications go away. So really try to automate that fault detection. So VMware provides some very cool technology to give you some level of virtual machine availability. But the real gaps of the VMware solution is to provide application awareness. So things like VMware HA, VMware Fault Tolerance, and Site Recovery Manager are all great, but they've got no real key application awareness. And that's really where the gaps lie. And those gaps are certainly areas which Symantec have traditionally been very strong in providing a solution for. Things such as application restart. So if the application dies, then how quickly can we recover the apps? An application failover. Historically, VCS has been a very strong clustering technology on Unix and Linux platforms, and also on Windows as well. So really what's needed is an approach to provide a level of application failover from one virtual machine to the other, which doesn't prohibit the use of the likes of vMotion and DRS, but also works hand in hand with the likes of VMware HA and also Site Recovery Manager. So really integration is key, and that's something which Symantec has been working on for the past couple of years now to provide a solution. So what I'm going to do is really go through how Symantec can help recover from VM corruption and also logical failures as well. So with that, we're going to look at the new features and functionality of Veritas Cluster Server, or VCS. Also with that will be application HA, and tied with that with obviously VMware HA as well to provide some level of VM resilience. So in this new solution from VCS, what we're doing is actually utilizing an API from VMware, and that's the hot plug API. Veritas Cluster Server, or VCS, is controlling access of the storage to the VM itself. As I mentioned previously, what typically you have to do is share the storage in a typical cluster using raw device mappings. With this new functionality of VCS, you don't have to do that. In fact, you don't need to do that. What we do is actually control access to the virtual machine directly from within VCS itself. So we're utilizing this API, which basically attaches and detaches the disks from one VM to the other in case of a fault. And the demo will go through that in more detail. By offering this type of approach, we then have the ability to offer customers the ability to use things like VMDK files for data disks, as well as raw device mappings if you want to do that as well. But note here, the raw device mappings are not shared between the virtual machines, so therefore things like vMotion and DRS work fine. So a quick example how this works. So here I've got a couple of virtual machines which have been clustered together. So I have an online SQL which you can see with the green circles and lines depicting the dependency resources of the application which is running. So ESX1 has the virtual machine running inside that environment. Both virtual machines have a boot disk which obviously contain the operating systems of the applications, and the application data itself is sitting on a separate VMDK file in this example. So in the event that I want to do a graceful failover from virtual machine 1 to virtual machine 2 for the SQL application, then what it does, it basically starts to take the application offline. So we'll offline the SQL various resources running inside the virtual machine itself. So the SQL services, the data disk locations, and also the relevant other components such as virtual IP address all get shut down and go offline on the virtual machine 1. VCS will then detach the data disk from virtual machine 1, and basically what happens on the other virtual machine itself, it starts to online SQL. So here we're doing a graceful failover, we're just failing over the application from one VM to the other. So the SQL data is then attached to virtual machine 2, and then the relevant application is then started above that. And we'll go into more detail when we see the demo live. So note here we're not using vMotion or storage vMotion for the data disk itself. We're just representing a detach and reattachment of the data disk for the SQL application. So regarding virtual machine configuration, these are the two virtual machines which I'll be running on through the demo. So here we can see on the screen System 2. And System 2, I've configured it to have various virtual machine disks as data disks. And on those, what I'll do is create a drive letter and mount points for my SQL instances, database logs, etc. as well. So on the second virtual machine, which will be the failover target, and I can have multiple virtual machines as failover targets within VCS itself. We support up to 32 nodes in a cluster. And here the secondary VM basically has the same type of configuration. So it has a boot disk. The shared SCSI bus you can see is set to none, but there's no data disk. So data disk will move from VM1 to VM2, or sys2, sys3 in this case. Now finally, regarding application configuration, what I've done when I configured SQL is really point the data directories to the various file shares and mount points I created on the actual virtual machine, primary virtual machine itself. So here I've got a P drive, I've got my production data, and then I have my databases and logs pointing to various folders within those drive letters as well. So that's typically how the configuration is made up for the virtual machine. So regarding configuration, we have a wizard which basically configures the application for you. What we've done is we've taken the foundation of application HA. Now application HA, what that does, it provides a automated approach to configure an application. So the wizard will guide you through this process. So the wizard, there's various prerequisites in relation to what's required before you configure the wizard. And the wizard itself is spawned directly from the vSphere UI. So here we select the type of application we want to configure. So here I can select my SQL 2008 application that I want to configure. And then if you notice at the bottom of the screen there, the application wizard will actually go out and discover the relevant components directly for me. So really minimizing the effort required to actually configure and cluster the application itself. So the wizard has come back and it's told me what instances I've got running. I can then determine whether or not I want to do detailed monitoring in that environment as well. So if someone deletes a table, if the application goes offline for whatever reason, then VCS is aware of that and will interact and fix the issue if it can fix the issue itself. So once I've configured the application, the next thing to do is create the cluster. So it's already selected SQL sys2 for me in the background because that's where I spawned the wizard from. And now I can select my secondary nodes. So here I'm just adding in my sys3 as my secondary node within the cluster. And again, I can continue adding more nodes in that environment. So once I've done that, I then go through and configure the heartbeating links between the cluster. And those of you who have configured cluster before are probably aware of heartbeat requirements between those environments. And here the heartbeats could be over Ethernet or UDP, so it really depends whether or not you're using a routed or unrouted network for your heartbeat traffic. Next selection is regarding a virtual IP address or VIP. And again, that can be bound to various public adapters within those virtual machines which are running as well. And finally, we have a configuration summary, which just lets you know what's going to happen in that environment. So once I click next, then typically what happens is the wizard will go off and start creating the cluster for me, and then create the application configuration in the background as well. So once that's done, then what we have is the configuration displayed directly in the vSphere client. So we have a plugin which is directly coming from Symantec, which gives you control and availability for the application as well. So here I can select my virtual machine. I can see the application which is running. I get various information whether or not it's offline or online or faulted. I can also get a view straight away of the application status, so I know my SQL application is currently running online on system 2. I also get my component dependency view as well, so those of you who've used VCS on physical environments, this view will be fairly familiar to yourselves. So here I can see my various resources which are running. I've got my SQL applications at the top there. In the middle I've got some storage configurations such as mount points and drive letters. You can see the NIC and the virtual IP address in there. And also the bottom resource is basically the new resource which manages the attachment and detachment of the VMware disks from one VM to the other. There's also going to be application operational controls there. So here I could is where I could switch the application from one VM to the other. I could clear a fault. I could stop or start the application as well. So that was good. We saw how we can look at a single VM and see what's happening. With VCS, we also have a dashboard view as well. So those of you who have used Application HA are probably familiar to this. So here what I can do is I can select at the data center or cluster. I can then get a straightforward view of what's happening in that environment. I can see all my applications which are running, what nodes are faulted or online. All my systems are currently online in this example. Again, there's some batch operations, so I can highlight a bunch of virtual machine applications there and start, stop, and control those in a unified manner. Some more views here, so I can also look at the number of nodes which are participating within that cluster. And again, I can drill that down and carry out various operations within that environment as well. So with that, I'm going to switch to the demo. So as I mentioned during the presentation here, we've got a couple of systems which I'm going to be working on. Basically, System 2 and System 3 are both running SQL. I've actually got SQL clustered on both environments. I've got a production SQL instance and also a UAT instance. For this example, we're going to be working on the production instance, which will have the ability to fail between Virtual Machine 1 and also Virtual Machine 2. So with that, I'm going to switch over to the demo now, and we'll go into that in a bit more detail. Okay, so on my screen we'll have the demo environment. So as I mentioned during the presentation, we're going to be working on two systems, System 2 and System 3. So both of these have the SQL application installed. They've got an instance also configured for both of those. So in this example, we're going to be looking at the clustering of the production instance. So I've highlighted System 3 at the moment. You can see the various configuration for the virtual machine. It's currently sitting on host 102, so that's 192.168.0.102. And if we look at the information on the actual virtual machine itself, so I'm just going to go and edit the settings. So we can see straight away that the SCSI bus is currently set to none, so it's not sharing the SCSI bus for this virtual machine. We've got a number of hard drives on the virtual machine itself. So here I've got a boot disk, and then the other hard disks, disk 2 and disk 3, those are the data disks which I've then configured with drive letters and also map points. So on here I've created the P drive for my production and also the map points within there as well. So these are the two data disks which are going to move really from System 3 to System 2 if we do a graceful failover or if there's going to be a fault in that environment. So what we'll do now is we'll quickly look at the other system, so System 2, and we'll just check out the configuration of that virtual machine. Okay, so System 2, notice here that System 2 is actually running on a different host. So this is running on host 192.168.0.101. So here the reason why I've split these up is because I want to demonstrate the vMotion capabilities of the configuration as well. Here I'm using VMDK files for the cluster, and I'm also having the ability to vMotion the virtual machines around the environment as well. Okay, so I'm going to look at the settings and the environment. So again, my SCSI controller is set to none for sharing. I've got the boot disk, which is hard disk 1. And this example, hard disk 2 and 3, those are the UAT production instances running on SQL. So here just highlighting really I've got an active cluster configuration. My System 2 here is not a passive spare, it's actually running an environment as well. Okay, so I'm just going to highlight System 3 and we'll look at the Symantec High Availability tab which I mentioned during the presentation. So straight away we can see the application current running status. We know it's running on System 3. If we highlight that, we can look at the dependency view of that environment as well. So here I can see my dependency view. At the top there I've got my SQL instance running, so my prods for the agent as well as the database. And then on the left hand side I've got my NIC, the IP address and the virtual server name. And then below that I've got my hard disk configuration such as map points, drive letters, etc. as well. So again, just notice the last resource in that tree. So the bottom resource, the VMware disk resource. This is a resource which will be managing the attachment and detachment of the disks from one VM to the other. Okay, so let's go straight away and actually cause a fault on the production instance. So what I've done, I've got a batch file which basically just kills the database from running. Okay, so we're just killing the SQL application. Okay, so straight away we've detected a fault, and what's interesting actually about the fault detection within VCS is we're not using the traditional method of polling the resources every minute or so. We're using a feature inside VCS called IMF, and IMF stands for Intelligent Monitoring Framework. So really what this has is kernel level monitoring of those various resources, and really think of that really as if you had a laptop with a network cable connected to it and you unplugged it, you get notification really quickly. So again, IMF is similar to that type of vein in detection of that fault. Okay, so now the fault's been detected, what will happen is the application will move over to System 2. So if I just refresh my screen, we can see the application is starting to actually come up on the secondary node. So it's already started to attach the various data disks for the production instance. It's now mounting up the drive letters and mount points within the actual storage itself, and now it's actually starting the production instances on SQL. So that was it. That was the failover of the SQL from one system to the other. It is very quick detection, also failover as well. So what we'll do now is we'll quickly look at the settings of the virtual machine. So again, I'm highlighting System 3. And here you can see that the configuration is pretty similar to what it was at the start, but we've actually lost hard disk 2 and hard disk 3. And as I mentioned, obviously those are the disks which are containing the data, and those disks will get moved from this virtual machine to System 2. So we'll just check that out now. So if we look at System 2, go to the settings, and now System 2 has got its production instances running on there in hard disk 2 and 3, and also the original boot disk and also the UAT instances are running on hard disk 4 and 5. So again, we can see the configuration is identical and everything's moved over as it should. Okay, so that was really the fault detection and failover. As you saw there, it was fairly quick in remediation of the fault itself. So what we're going to do now is just clear the fault. And what I want to do is really demonstrate what happens actually inside the virtual machine. Appreciate that we're looking at the virtual machine from the vSphere UI point of view, but ideally you want to have a look inside. So now I'm just going to switch to a different view. We're going to do this live as well, so you'll see the actual running and failover times as noted in the clock at the bottom as well, so you can track those. So I'm now going to switch over the application from one VM to the other. So this is a graceful failover as opposed to a fault. And here you can see the Java console which we use typically for VCS on physical. And it's just been displayed here really for your reference, so you can see what's happening actually inside the virtual machine. To the right of that, you've got a HA status running in the command prompt. So again, just get a running view of what's happening on the cluster at the back end. On the Explorer view, you can see the various drive letters there, C drive and P drive. So the P drive is the one which is going to hold the SQL data for the instance itself. So this is the P drive which will disappear when we actually do a failover. And at the bottom there you can see the SQL resources or services which are running. Okay, so let's start this back off again. And we can see there the mount points are being taken offline, the P drive is now gone, and again the SQL services are stopped. Now if we switch to the secondary VM, so this is back on System 3, we can now see the data disk being attached, and then what we'll see is the drive letters come online. So again, there we go. We see the P drive come in, and mount points are there. It's now applying the virtual server name, and now it's starting the SQL services to that environment as well. Okay, if we do a refresh, we can see that SQL is now online. So the production instance is now running. The P drive is now visible to this virtual machine, and the application is up and running. And the time it took there is around about 45 to 50 seconds on the failover time. So again, it's fairly quick. So if your SLA is determined by how quickly you can recover, so if you're looking for a quick recovery point objective, then really VCS is giving you that functionality. Okay, so if we switch back to the UI, you can see there that SQL is actually running fine on System 3. So as I mentioned during the presentation, typically if you are going to cluster inside a guest, you've got to use raw device mappings, which means you can't use things like vMotion, DRS. With our solution you can. So this next part of the demo, what I'm going to demonstrate is really how we can actually do a switch over during a vMotion event. So next example, what I'm going to do is actually vMotion, and again just keep a note of the host IP address. So currently System 3 is going to be migrated to the 101 host, and at the same time I'm going to switch over the application. So the virtual machine is being moved via vMotion, and then the application is going to be moved to System 2 via VCS at the same time. Okay, so migration is now kicking off, so vMotion is starting. So if we highlight System 2 and then basically do a switch over from within System 2. So here I'm now going to switch, highlight System 2 as the failover node. And again, just get a view internally of what's happening in that environment. So again, all live, you can see what's happening. Same process, determining the offline status and offlining the P drives, detaching the disks. So if we switch over to the virtual machine, we saw that migration is finished, and now the failover node is starting up. So I'm just going to pause it quickly so we can see now that the migration has completed. So the vMotion event is finished, and if we look at the status of the virtual machine, it's now starting to online the application running on System 2. So we're fully aware of the vMotion event, and we basically just make sure the vMotion event is completed before we actually start the virtual machine information up on the secondary VM, in this case System 2. So we can see here that everything is now back up and running. Roughly took about 3 to 4 minutes, the failover time itself. So again, depending what happens during that vMotion event, if a fault happens, then VCS is aware of that fault and will determine a remediation event for that and fix the issue for the application itself. So with that, I'll complete with a summary, and thank you very much for spending the time to watch this demo.